Okay, for part 2 of this section, we're going to focus on difference of squares. Okay, so when you see the word difference, remember that just means subtraction. Okay, so when you see difference of squares, we're referring to something squared minus something squared. Anything that can be written that way can be factored as that first thing plus the second thing, the first thing minus the second thing. And honestly, the order of this doesn't matter. You can put minus then plus, you can put plus then minus. Doesn't matter. Okay? Something we want to watch out for, right, is a squared plus b squared, right? That's not anything. That's sum of squares if you want to call it something, but that doesn't mean you can factor it. Okay, so we're going to ignore that for now, and we're going to focus on difference of squares. Okay, these occur a lot, especially in college algebra, so you want to be familiar with how to handle them when you see them. Okay, they're generally pretty easy to deal with. Pretty easy. Example 1, let's factor x squared minus 16. Okay, so if I were to see that, I immediately think difference of squares because I see something squared minus, and then 16, which technically is something squared, right? It's 4 squared. In other words, I can think about this as x squared minus 4 squared, right? You can think about it like that. If that is true, then this factors to x plus 4, x minus 4. And that's all there is to it. Okay, I just put x squared. That's kind of funny. Example 2, 16x squared minus 1. Okay, can I think about that as something squared minus something squared? Okay, well, that first part, 16x squared, is 4x being squared. Minus 1 is technically 1 squared, right? 1 squared is 1. So I can think about that as 4x squared minus 1 squared. In other words, this factors to be 4x plus 1 times 4x minus 1. Example 3, 49 minus x squared. Sometimes if you put the x as the second term, it confuses some people. Don't let it confuse you. Okay, again, it still fits the mold, right? 49 is 7 squared. X squared is x squared, right? So this factors to be 7 plus x, 7 minus x. See, I didn't even have to write out that second step technically, right? That 4x, like I did in the last one, right? Where I did 4x squared and 1 squared. You don't have to write that out. If you think about it and you see it, you can just write the answer. And that's really what we want you to do once you get to these types of problems. Example 4, 4 plus 9x squared. Okay, well, 4 is 2 squared, right? That's 2 squared. 9x squared is 3x squared. Okay, but before I write this out, I hope you recognize that that was a plus, right? So it messes it all up. This is not a special factorization. There's nothing special about 4 plus 9x squared. It's not difference of squares. Remember, difference is subtraction, so definitely not difference of squares. All right, moving on. Example 5. 9y squared minus 25x squared. Okay? So let's think about this. 9y squared is the same thing as 3y together raised to the second power. I have a minus sign, so it's difference. And then 25x squared can be thought of as 5x raised to the second power. So this thing will factor to be 3y plus 5x, 3y minus 5x. Okay, let's get to some that are a little bit more challenging. So example 6. Here we have 8y y squared minus 18x squared. Okay, just looking at that, it doesn't seem to be quite difference of squares. Okay, but remember, we should always be checking for common factors. Okay, and so in this case, a common factor would be 2, right? They're both divisible by 2. So I could think about this as 2 times something. What would that have to be? If I divide that by 2, that's going to be 4y squared. And if I divide this one by 2, it's going to be 9x squared. Ah, that looks like difference of squares. The question is, what goes in the blank? Well, 4y squared is 2y squared. Nine x squared is 3x squared. Well, look at that. We factored it. Okay. These should be quick, right? They should be quick. So when you're working out a problem that's a complicated problem, but you come across a difference of squares in the middle of it, you should still be able to factor it without losing too much time. Okay, let's do 12x squared minus 3. Again, I'm going to need to factor out a common factor first. 12 and 3 are both divisible by 3. If I divide this by 3, I get 4x squared. If I divide this by 3, I get 1. 4x squared minus 1 is difference of squares. Okay, well, 3. What is being raised to the second power to give me 4x squared? That'd be 2x. What's being raised to the second power? That gives me 1. That's 1. So 3, 2x plus 1, 2x minus 1. Okay, let's do one more example. Okay, this one says 4x to the 4th minus 9y to the 4th. That looks tricky. Okay, so let's think about this one. Something squared minus something squared. Okay, in order to get 4x to the 4th, I would have to raise 2x squared to the second power, right? Because if I took this 2 and I squared that 2, I'd get 4. And remember, if you square something that already has an exponent, you just multiply the exponents together. 2 times 2 is 4, so that'd be x to the 4th. Same thing is true for the 9y to the 4th. 3 squared would give me 9. Y squared would give me y to the 4th. So this factors 2x squared plus 3y squared, 2x squared minus 3y squared. Okay, and so there we go. That would be difference of squares, and that wraps up the special factoring techniques.